Now we're going to take a look at section 6, which is going to be two parts. The first part being graphing piecewise defined functions, and then the second part will focus on shifting and reflecting graphs of functions. A piecewise function is one where more than one equation is used to define the output over different intervals of the domain. When evaluating a piecewise function, we have to use the correct equation that corresponds to the appropriate interval. So here what we want to do is evaluate our functions for some different points, but realize that our function is broken up into two equations. For all values in our domain where x is less than or equal to 0, we're going to be using the equation 2x plus 3. But for all values in our domain greater than 0, we have a different equation to use. So when we're trying to consider which part we're going to use, we have to see which of the inequalities is satisfied. So for f of 2, we have to think, is 2 less than or equal to 0, or is 2 greater than 0? Well, because 2 is greater than 0, f of 2 is going to equal, we're going to be using f of x for negative x minus 1. Therefore, f of 2 will equal negative 2 minus 1, which gives us the value negative 3. If we want to evaluate f of negative 6, is negative 6 less than or equal to 0, or is it greater than 0? Well, it's less than or equal to 0. So because negative 6 is less than or equal to 0, we will be using the function f of x equals 2x plus 3. So f of negative 6 equals 2 times negative 6 plus 3, which equals negative 9. And last but not least, f of 0. Well, f of 0 is less than or equal to 0. So because 0 is less than or equal to 0, so I'm going to write it down here, we will be using 2x plus 3. So f of 0 equals 3. So we're able to evaluate each of those functions. Let's do it again. I encourage you to pause here and try it on your own. Here we have three functions. Our first segment is for all values less than or equal to 0. Our second segment is all values between 0 non-inclusive with 5 inclusive. And then for all values greater than 5. Let's start with f of negative 2. F of negative 2 is going to use x squared minus 1 because negative 2 is less than or equal to 0. Next, we're looking at f of 0. Again, 0 is less than or equal to 0, so we'll use x squared minus 1 again. Next is f of 5. 5 is in this interval where it's greater than 0 but less than or equal to 5. And so we're going to use the equation 2x minus 1. And last but not least, f of 6. Well, 6 is greater than 5, so we're going to use f of 6 equals 3. And that's our answer. There's nothing else to evaluate. F of 6 equals 3.